welcome to another episode of FooBar. Today I want to show you in action one very useful pattern when working with distributed applications, the Saga pattern. The Saga pattern helps us to handle failure between different microservices in a distributed transaction. In this video, you will learn more about the Saga pattern and also how to implement it with step functions. So let's get started. When you're working with distributed applications, failure is impossible to avoid, so don't even try it. As Amazon CTO Werner Vogels always says,
remember, everything fails all the time.
You need to design and build your applications with failure tolerance in mind. We have migrated from monolith to microservices. In all the work was done inside one service. And now we have a scenario when all this work is done in multiple microservices that does part of the work. In this microservice scenario, you have these distributed transactions, and this is a transaction that spans over multiple microservices, in where each microservice has its own data storage. This is one of the things we love about microservices. Now, microservices are decoupled one from another. We can scale them, deploy them, and maintain them independently. But how we roll back a distributed transaction that has some kind of partial failure, meaning that one part of our transaction fails. When we are working in a monolith, in a local transaction, we just roll back the action in the database. But when we have this kind of distributed system where the transaction is spanning multiple microservices, you have to have another approach to establish the consistency when a failure happens between these different microservices. One common error that we have seen is that basically you roll back the error locally, but then other parts of the transaction don't realize that there was an error, and it takes longer for the error to propagate, and there can be data inconsistency issues. To solve the problem, we have the Saga pattern. A Saga is defined as a series of steps. In each step is doing some work that has side effects in the data sources. The steps are discrete and local to a microservice. In most of the cases, the Saga will go through and the transaction will end up successfully. However, in some cases, there can be an error in one of the steps. And the Saga pattern states that we need to have a compensating action for every step that performs works with a side effect. When it comes to the implementation of the Saga pattern, we can implement it in choreography or in orchestration scenarios. If you don't know what are these patterns, I'll leave you a video in the description box where you can learn more about these two patterns and the difference. For this video, I want to show you how you can do it with step functions using the orchestration patterns that a step function provides. If you have been seeing the series about step functions, maybe when I mention a Saga, that is a set of steps that perform work in discrete things, and you were like, that's a step function. Yes. So step functions allows you to really easily implement this pattern when you call the right APIs in the different microservices. So if we model the previous example that I was showing you with little boxes, with step functions in a workflow that looks something like this, each step of the workflow, in this particular case, calls a Lambda function, but it could call an external API or API gateway or whatever you want. And in this case, in case of success, the happy path, everything ends normally and we are good. Everything is good. But if the first state fails, for example, then we can do a fallback state that executes and that calls the canceling, in this case, of the booking of the hotel. And this is basically using the step functions error mechanisms that we have a whole video on that, how to do fallback states. If the failure happens later in the transition, now the fallback state for that transaction will trigger, in this case, we fail the booking of a flight, we cancel the flight just to make sure that everything is clean, and then we cancel the hotel booking because we need to fall back as well the previous step. And we need to compensate any other step that has done some work. And here we can see it in action when the last step in our transaction failed, and in this case is to book a car. The fallback state will trigger cancel the car, cancel the flight, cancel the booking, and things like that. So let's see this with code and how this can be done with step functions. So let's see the previous state machine in action. I have it here. It looks very ugly because this is the way that it was drawn. But it does the same. We book a hotel. It works, we book a flight. If it works, we book a car. If the hotel fails, it cancels the hotel, ends, book a flight, cancel the flight, cancels the hotel, book a car, cancels the car, cancels the flight, cancels the hotel. Exactly what I show you, and everything is done with fallback states. So let's run this, and these bookings are Lambda functions that has a 20% probability of failing. So let's see, now book a hotel fail. So we went to cancel the hotel and to end. We can run it again, and we can see now book a hotel succeed, book a flight fail, and then cancel the flight and cancel the hotel. And let's try it again, see what is the result we get. And then everything went through. This is basically the state machine. And how this looks, let's see it in action here. Let me open the template YAML first so I can show you a bit. We have here our state machine. State machine has 6 Lambda functions, 3 for booking and 3 for cancels. It can be HTTP external endpoints, or it can be calling API gateways or Fargate task, whatever you need. But for simplicity, I just use Lambda here. It has all the permissions, and here we have the state machine. And then we have the different Lambda functions, and these are just very simple functions that don't do much. So we have the booking one, book a hotel, book a flight, book a car, and they all have 20% chance of failing. And then the cancel is basically just canceling and calling the function, not doing anything work. So you can make this your own. Then we have the state machine, and this is the nice drawing I showed you before. And here we have again the 6 different states. So each of the states is more or less the same. We have some retries in case of there's some time offs or failures. We can retry a couple of times, for example, for errors. We have the fallback state here, and for example, in this one is booking and canceling the hotel. And then each of these state is a Lambda function, a task state, and we don't do much. We just invoke the function. And they're all more or less the same, and they just bring this state machine. You can find the code in GitHub, so if you want to recreate this at your own, you can do that. It's available in GitHub for you to try it out. And that was the video for me today. I hope you like it. It's a video where I want to show you a little demo with something that we talk a lot, that is the Saga patterns. This is just a pattern. You need to put your logic, you need to integrate it into your own applications. This is just an example, but the code is available for you as always. And if you want to learn more about step functions and how it handles the errors, I have made a whole video on talking about retries, fallback states, and more, and I leave you the link in here. And if you want to learn everything about step functions, you can find this playlist that is here. It's like a whole course for free on step functions, so have fun and let's learn more step functions. And I see you in another episode of FooBar.